Okay, so we're going to continue today talking about Chapter 5, and we probably will also have a chance to start Chapter 6 today. Last lecture we talked in some detail about the bank accounts management problem. What we're going to do today is we're going to work on the airline example, and which is explained in detail in the book a little bit, and also start talking about the operations and responsibilities a little bit as well. So this problem is presented here. I'm not going to go over it in detail like I did in the last one, but I'm just going to sort of walk you through some of the important relationships so that we can see sort of the first step, and later on we're going to talk a little bit about how some of the details plug into this problem when we get into the operations. So we've already seen passenger, booking, and specific flight. We looked at that a couple of lectures back when we talked about the association classes. Okay, we said that a booking is the association class. Booking has one passenger, one specific flight. Okay. Another thing which we will find important is the fact that we've divided up the problem into regular flights and specific flights, where regular flights have a time that they go every day, and a flight number that is the same every day. Whereas the specific flight is the occurrence of that flight on a particular day. And this is what passengers book on. Passengers book on a particular flight as opposed to the general flight that goes day after day after day after day. You've got to tell people what day it's going to go on. The specific flight is also the thing that has an airplane on it. You know, the airplane is assigned to a specific flight. Different days they might use different planes. Although they would often use the same type of plane, but they might use physically different aircraft. And another thing we have is we have the notion of assigning employees to specific flights. These are the pilots, and the job function might be pilot, might be co-pilot, might be steward, stewardess, etc., etc. And we also see an example of a reflexive association here. Can anybody tell me in this diagram where there might be possibly another opportunity for an association class that we haven't actually shown here? What are the circumstances in which association classes are typically found? What should flag you that there might be an association class, or we should look for one or think of the possibility? Nobody has a clue. Okay. Well, you're going to have to do better. Yes, this guy here has got some ideas.
Well, anytime there's a many-to-many.
Anytime, okay, right. Anytime there's a many-to-many association. Good, okay. Got your brains warmed up a bit. So are there any many-to-many associations here? Employee to specific flight. So the question is should there be an association class there? Is there information about this relationship, the individual case of this relationship that might possibly belong there? And what would this class be called if we added one? Assignment, allocation? Sorry, what were you going to say?
Flight crew.
Flight, okay, flight crew. Flight crew, possibly. I think assignment to flight crew or crew, you know. The word flight crew implies the set to me. It implies many things. So it's crew member or you know, but it's an assignment of an employee to a specific flight. The word assignment is a common name, or allocation is a common name for association classes. And if we were to do that, then we would want to say, well, there must be data associated with that assignment. Okay. So maybe, for example, employees have two job functions. One job function is pilot or air crew, and another job function is particular related to the steward, stewardess, or cabin staff, cabin crew, I guess would be the word. Those are the two employee roles that fly on flights. But in terms of the actual allocation, a given pilot one day could be the main pilot, another day he or she could be the co-pilot. And in terms of cabin crew, one day a particular person could be dealing with business class or a certain set of seats. Another day they could be dealing with the economy class or a certain set of seats. So you could imagine that the allocation would tell them the particular role they're playing on this particular flight. So that's just as a thought. Anytime you see models, analyze them a bit. Think about them. Are they valid? Is there anything wrong with them? Okay, let's move on to slide 48. As soon as my computer's warmed up and decides it wants to actually respond to the key. Good. Let's talk about identifying generalizations and interfaces. We had a couple of generalizations in the bank account management problem we dealt with last class. One of those was that we could have had the possibility of having bank branches as subclasses of some kind of organizational unit or some kind of organizational division. And we also could have had the notion of having our clients and our employees as subclasses of persons. So we identified a couple of generalizations. There are two ways that when you're doing modeling that you look for generalizations. One way is bottom-up. Okay? Bottom-up says you see two similar classes, like employee, like a client, and you say there's something similar about these. They have a name, they have an address, they have a phone number. And therefore what we should do is create a common superclass, okay, which is going to capture those commonalities so they inherit to the subclasses, so we don't have to duplicate. So look for commonalities. Look for anywhere you see the same attribute name, or attribute names that are not necessarily the same but very similar in name. Maybe what you need to do is to change the names to make them the same because they have the same meaning. Ultimately, it's the meaning that counts. And you put the common meaning in the superclass, give it a common name that will then inherit. Another approach to identifying generalizations is top-down. This is the approach of saying, I have a class, and maybe there's subclasses of it, and I'm not sure. So, for example, we saw that with our account. We started with account, and we say to ourselves, are there any subclasses of account? And then we say, yes, there are. There's mortgage account, and so on. All right? So you look for the general classes and specialize them if needed. In both cases, you've got to make sure that when you add classes, either superclass or subclass, that there's going to be a valid reason for it being there. Bottom up, it's usually easy. You're collecting together common features, common attributes, common association, common operations, put them in a superclass. Those common things are the reason for that class to be there. But when you're going top down, be careful. Remember we saw those cases of making all the different types of music, classical music, rock music. Well, we don't need separate classes. So top down is dangerous because you sometimes go whole hog and have all kinds of classes you don't really need. The next point is, well, interfaces are very much like classes. So should we create an interface instead of creating a class? Okay? And the basic answer to that is that you're going to create an interface in situations where you have operations only that need to be used in multiple places, and you don't want to make a superclass for one reason or another. Maybe the is a relationship doesn't hold. That's the obvious reason. If the is a relationship doesn't hold, you never create a generalization. So you're going to think, okay, well, I still might have some common operations. There's not an is a relationship, still common operations, therefore an interface might be the way to go. Okay? There might also be some possibilities of different implementations of the same class. So we saw the possibility of the point hierarchy where we had different ways of implementing points, things like that. And I could make superclasses there. Sometimes I do interfaces because there's more than one way of making superclasses. I've already got a class that has a superclass. And I could make another superclass in C++, but if I'm working in Java I can't, and therefore I use interfaces instead. Okay? So, think. When you're making generalizations, also maybe there could be some interfaces around as well. On slide 49, we see a modification of the airline problem where we have now added a generalization. I've generalized my passenger and my employee to make a person superclass. But I've also done something rather interesting here. I've done one step beyond a generalization. I've also created a relationship between a thing called person role and a class called person. And the reason why I've done that is because it might be that a given person is both passenger and employee. Some days I fly as a passenger. Other days I fly as an employee. Okay? In my computer system of my airline, I might want to just have one record of the person with their name and their ID number, okay, which does double duty as a frequent flyer number and as an employee number. But, and that way I can say, well, okay, pilot Mary Smith today is flying to Honolulu, and she's flying back overnight. Well, she's certainly not going to fly, you know, the plane back. She's going to be as a passenger, right? So that allows me to put people who are employees as passengers on flights. Okay. If I didn't have this separate class over here, person, and use person role as a superclass of passenger role, employee role, I would have to segregate people as either instances of employee role or instances of passenger role. And they couldn't be both. In this case, everybody can be a person, and I can tag, I can associate with person an instance of passenger role, which has bookings, and an instance of employee role, which has specific flights. I can have both, I can have one or the other, or I can have none if I didn't happen to have any yet. Okay? So this structure is an interesting structure that gets rid of this problem of having to have an instance change class. But yet still allows me to have inheritance. I'm inheriting the properties of person because the association from person to person role is inherited by passenger role and employee role. So an employee role can find out the name and ID number, and so can a passenger role. They just say, get my person's name, or get my person's ID number. So we still have that information available to both. We're still taking advantage of inheritance, but we get rid of that pesky problem we talked about 2 lectures ago of objects having to change class. We don't want objects changing class. Any questions about this? We're going to see this particular thing coming up. This is called a pattern. When we get into chapter 6, we're going to see other cases of this, and we're going to realize this is common. It's appearing over and over again. Well recognized in software engineering as a way to do things. Let's move on now and start talking about the actions and operations and methods, basically the computations that we're going to have to do. We're going to start off by naming things which we're going to call responsibilities. Responsibilities are generalizations of operations. They're just, I write them down as simple sentences of things that a class has to do. One of the strategies that you can do when developing classes is to take an index card on a piece of paper, one per class, and just write down on that index card everything you know about that class, all of the attributes and all of the things that you're going to have to implement in that class. Okay, these cards are sometimes called CRC cards. Okay, class responsibilities and collaboration. There's a description of that in the book. I'll leave you to read that. But the responsibilities are basically what this class is going to have to do. They might be implemented using one operation, several operations. We'll work on that in a little while. Okay? Generally speaking, each functional requirement is going to be attributed to one of the classes. So each functional requirement is going to be put in, generally speaking, into one class as a responsibility. And the responsibilities as a whole of a class should be related. So the responsibilities of student have to do with, adding courses to the student and changing the student's name and things like that. Responsibilities of a booking involve assigning seats and adding the passenger and adding the flight and things like that to the booking. Okay, so they're related to the fundamental purpose behind having that class. They're things that typically modify the data or access the data associated with that class. Sometimes you discover at this point you've got way too many things that a class is doing, in which case split it into distinct classes. Maybe we want to split up a class into subclasses or separate out a class into a separate bank branch class and an address class. So we've got all the modification of address goes on in one class, and the bank branch has an address, but it's fundamentally responsible for a smaller set of things. Okay? Too many responsibilities is a problem. Too few responsibilities in the class is useless. Okay? Class has to have some things that it has to do. And if you have any functional requirements left over, then think, maybe they belong in some class we haven't got in our model yet. So even at this point, we've already got our first draft of our diagram done. There might still be situations where we have to add new classes. How do you work out the responsibilities? Well, use case analysis is a good approach. We talked about use case analysis briefly in Chapter 4. In use case analysis, we had the user does something, the system responds. The user does something, the system responds. For all the possible things that the user does and the system's responses. So those systems responses can be the responsibilities. Okay? And so if we think, well, which class is going to have the operations and methods that do each of those responses? Sometimes they're going to be in the user interface classes, in the architectural classes. Other times they're fundamentally going to be classes that are in part of our domain model. And it's the verbs that describe actions, and nouns sometimes describe actions too. There are nouns, in English language, some nouns and verbs are closely related to each other. So although you're looking for verbs, occasionally some nouns become actions as well. Okay. So for example, if somebody said, the system will make an assignment to employees. Well, make is a verb, assignment is a noun, but make an assignment together is a verb phrase, and that becomes an operation. Okay? On slide 51 is a sort of catalog of typical kinds of responsibilities that you're likely to find in systems in general, in classes in general. I suggest that what you do when you're going through each of your classes trying to figure out the operations is to go through saying, have I got operations or responsibilities for setting and getting the values of attributes? Fundamental. Okay? You can make your attribute data public and get away without doing this. But generally speaking, we recommend strongly that you have get value, set value type methods. So get date, set date. The reason why is that allows you to change the internal structure of the class later on. Okay, so getting and setting attributes is one major class of responsibility. In creating and initializing new instances, okay, so obviously the constructor of a class is going to be involved in that, and in fact we might very well map some of the responsibilities to constructors explicitly. But we might also have operations in one class that call and create a related object in another class. So I might, for example, have a method in passenger that says make booking. So it calls the constructor of the booking class. And so that will be a responsibility in the passenger or passenger role class, whose responsibility is to make the booking. So you go through looking to see if you can find any of these. Obviously, at some point, every single class has got to be created. There's got to be instances created. So there's got to be a constructor for every class, and ultimately there's got to be a responsibility for calling that constructor somehow. Sometimes it's the user interface that does that. Other times it's done internally by classes in the domain class set. Loading or saving from persistent storage is another kind of responsibility. We haven't talked about that. In the early stages of design, I deliberately avoid talking about database design and loading and saving from storage. I leave that typically to my designers later on. But it nevertheless is something which we are eventually going to have to put in as a responsibility of classes. And it would, as I say, come in the latter stage of design, not the early analysis stage. Destroying instances. When are we going to get rid of bookings? When are we going to get rid of flights? Okay, if we're ever going to get rid of instances, there have to be responsibilities for doing that. Some class has to have some code in that is going to say delete. Okay? Adding and deleting links. These are fundamental. Okay? Creating an assignment of an employee role to a flight. Creating a new credit, sometimes creating a new instance goes along with creating the association to it. So creating a new instance of credit card goes along with creating a link to that. Other times, you're creating a link between classes where you're not creating a new instance of the class. So creating a new prerequisite association between two existing courses. Okay? So you're going to need responsibilities for adding links and deleting links. And you have to think which links are going to need to be added, which links are going to need to be deleted. You're going to have responsibilities for doing that, which will map to one or more methods eventually. In fact, as we'll see, adding and deleting links usually requires more than one operation to be done. So one responsibility maps to several operations because it's a several-step process. Copying, converting, transforming, transmitting, outputting. Basically, these are all similar type of thing. You're taking data in one form and converting it to some other form. Okay? So you're taking say a transaction, a bank account transaction, and you're printing it out on a bill. Okay? That's one kind of this process. You might be transmitting an object from a client to a server. Okay, they're all very similar. They basically involve formatting the data in some coding scheme and transmitting it or outputting it. Computing numerical results, how many, or what's the average, or what's the standard deviation, or what's the sum, things like that. Navigating and searching, very important, very essential. All the kinds of queries that you might want to do in the model, like how many students are enrolled in this course that took its immediate prerequisites last year. So I'm going to have to, if I'm going to do that, I'm going to have navigation from this course to its prerequisite, get the prerequisites, that's navigating associations, and then I'm also going to have navigating from this course to its prerequisites as well to get the courses last year. Searching, finding all the names match, all the instances matching. So find me all the bookings who's with passengers named, I don't know, give me some name, Wong. Okay, okay. Find all. We know that there's an urgent call for passenger Wong on the flight. We don't know Wong's first name or last name. We're going to do a search. So we're going to go to the flight, we're going to look through all the bookings, we're going to go loop through all the bookings, matching the name, seeing if they match the name Wong, and when we find Wong, we're going to output them and send them off, you know, saying, okay, we found these passengers called Wong, and we don't know, could be more than one, and the user interface can display those, and the person can do what they want with that information. So we're going to have to create responsibilities to do that kind of thing. Okay. Sometimes in your requirements, not all of these responsibilities are actually specified. You might find that the requirements don't actually tell you in detail all of the navigation things that you're going to have to do, all of the searches that you have to do. You know, the users expect that they'll be able to search for things. They expect they'll be able to search for flights, they'll be able to search for passengers, they'll be able to search for other kinds of information. Vacant seats. Find me a seat, the seat nearest the front of the plane that's vacant. Okay? That's a search operation, looping through a set, finding a match. Okay, that might not be specified initially. You might have to go through and work with your users to find out the kind of searches that they really do in the data that's being represented. And there may be other kinds of specialized things not in these categories. The point is go through this checklist, seeing have you in fact captured all the responsibilities in all of these categories that you need in your problem. But don't do too much, as always. Don't try and do unnecessary things beyond the problem scope. Any questions? So we're going to look at a few of these. On 52, slide 52, I've got some responsibilities listed. Okay, so creating a new regular flight is going to be one of them. Okay, and if we go and look at slide, actually I'm going to jump around a bit here. Creating a new specific flight is going to be assigned to a particular set of operations. Okay, so creating a new specific flight is going to end up being assigned to Okay, I guess I don't have it on slide 55. It's going to be, we're going to have somewhere in here a class called Airline that is going to do things like create new specific flight. Or maybe that's going to actually be in no, I don't have it here. Okay. That all of these responsibilities shown on slide 52 are going to end up being implemented as associations. I'm going to go to slide 55 separately, and we'll take a look at some of those. Searching for a flight is another one. Modifying attributes of a flight, so modifying the time and flight number of a regular flight, or the date of a specific flight. Well, that probably we might not modify ever, but we might modify the time and flight number of a regular flight. Creating a specific flight from a regular flight. Booking a passenger, cancelling a booking. These are key responsibilities that we'll have to implement. And we'll implement some of those on slide 55 in a minute. As I mentioned the CRC technique that's described in the book. Okay, on slide 53, there's some of these techniques that will help you to work with these CRC cards. Okay. So, for example, I suggested writing the names on small cards and listing responsibilities on the cards, and then moving the cards around on a whiteboard with little sticky tapes. So maybe they're little yellow stickies. You move them around. You can draw associations. We did it on the board the other day. The board is one way. You can use an eraser to erase and redraw. If you do them with cards, you can sit around as a group and not have to erase, and you can add things to the cards, and basically the lines become the associations. Okay? So just some additional tips about modeling once you've got the responsibilities and attributes on your cards. Okay, slide 54 then. Operations are needed to realize the responsibilities of each class. And as I said, there may be several operations per responsibility, which we will see on the next slide. On the next few slides, I think. The main operations that implement a responsibility are going to be public. So there will be, for each responsibility, there will generally be one public operation and several private operations, or protected, or in Java's case, blanked, meaning subsystem-specific operation. Okay, so that allows our subsystem as a whole, our package as a whole, to have as its API one operation per responsibility, one public operation per responsibility on its API. Okay? The methods that collaborate, as it said, the methods that are used by the public operation are going to be as private as possible. And we're going to see how this works in a few minutes. Okay, so slide 55 then has a set of operations in it. And I'm showing plus symbols, which is part of the UML notation, indicating public. I'm also showing in square brackets some information. This is not part of UML. This is just my notation here to indicate to you the responsibility that we're dealing with. Okay, so I'm going to be dealing with responsibilities A, B, C, D, and E, and these things in square brackets are just simply showing you the methods involved. So for example, we should see A1, specify airplane, is going to involve in add link to specific flight in airplane, and I guess that's the only A there. So it's going to call this one. So add link to specific flight is a collaborating method. It's not public. It's going to be used by the public specify airplane method. And B1, create flight log. That's public. Okay? That is going to make use of the flight log constructor. Okay? I'm using flight log in capital letters indicating it's a constructor. Okay, that's B2. Okay, somewhere we have C1. Down in passenger row we have C1. Make booking is a public operation for the responsibility of making a booking. That is going to make use of a couple of other things. It's going to make use of C2, the constructor of booking. Okay? And it is also going to make use of C3, add link to booking. Okay, so in fact we'll see later on that make booking calls the booking constructor, which in turn calls C3 add link to booking, and C4 add link to booking in passenger row. So we've got add link to booking in specific flight, making a link from specific flight to booking, and we've got add link to booking in passenger role, making the link from passenger role to booking. So we're going to see several methods collaborating in order to do this booking process, which is responsibility C. Let's take a look at some of the details. Okay, collaboration A, responsibility A. Okay, this is the responsibility of specifying the airplane for a flight. Okay, now this is obviously done ultimately through the user interface. Somewhere in your system, you've got a user interface, you've got an airline controller who's choosing which airplanes are going to be used for each flight. This might be an automated process, in fact, an automated allocation. Maybe there's manual overrides. Somehow, that control from the scheduling system or scheduling interface is going to be passed down to the data that is stored about the flights. And there's going to be a link made between the specific flight and the plane that's going to be used on that day. Okay? There's a responsibility is going to be allocated to class flight. The public method that in this subsystem, this airline subsystem, that will be responsible for doing the allocation of the flight is the specify airplane operation in class SpecificFlight. However, it will collaborate with the airplane class. Fundamentally, what it's got to do, there's got to be a linkage made between the flight and the airplane. Notice, we're not making a new airplane every day. Airplane exists. The flight has been created months ago. The flight gets scheduled many, many months in advance. Okay? Only as we approach the day of actual flying do we actually choose the aircraft to be used. Because we don't know which aircraft are going to be down for maintenance, which aircraft are going to be delayed, etc., etc., etc. This is going to be a bi-directional link between two existing objects. The flight needs to have a pointer or reference to the airplane, because I need to be able, if I'm finding information about the flight, to be able to say, what plane is this going to be flying today? Notice it's a 0 to 1 association. We might not know initially, but at some point after this operation we will know. It'll be 1. Or maybe it was already known and we're making it change, make a new one. So 1 is what the result will be after the operation in the multiplicity. The airplane at the same time needs to know about the flight that it's going to be flying. There needs to be a log of which flights were flown by each airplane. The system that routes airplanes around gates and stuff is going to have a list of all the flights and the sequence of flights that are going to be flown. So it's bidirectional. We need a link from flight to airplane and airplane back to flight. Anytime you see bidirectional association, you're going to have two methods, because basically what's going to happen is you're going to have each class responsible for updating its own data. You don't want to have the specific flight class fiddling directly with the collection of flights stored in airplane. You want to have the specific flight class call airplane and say, please add the link back to me. Remember, we don't want to fiddle with data in another class. We want to call methods to do that. It's more flexible. It allows us to later on change the design of the data. So we're going to have two methods. We're going to have our main specify airplane method, public, it makes a one-directional link to the instance of airplane. And then it's going to call airplane's add link to SpecificFlight, which is going to make a link back from airplane to SpecificFlight. So each class modifies its own data. The airplane code add link to SpecificFlight is private. It should only be called by specify airplane. It shouldn't be called for any other reason, because if you do, you're going to end up with airplanes that are flying flights when the flight doesn't even know it. So these links have got to be made together. One made, the other made, and they're always done in pairs. If we ever delete the links, we're going to delete them both in pairs too. There has to be a method to delete the link on one end that calls the delete method on the other end, so that the link is severed. Okay? Everybody understand how this works? This is a standard way of implementing an association that is bidirectional, like this, where you have to add a link. I'm not actually showing you the code for this, but the code is available on the website. Actually, I discovered that it's not available on the website, but it will be very soon available on the website. So those watching the video will see it there. Code for actually doing this. Okay. But you also see this kind of code in a number of other situations in the labs and assignments as well. Any questions? We have class, two classes, making a link between them. Each class is responsible for its own side. But there's one general responsibility, which is specifying airplane, divided up into two operations. Class collaboration B. Okay, in this case, we are creating an object, a flight log, and linking it to a flight. So we're going to have a separate log for each flight. So the specific flight is going to be creating a log at the time when it's about to start flying. We don't create the log when we first schedule the flight, maybe. Maybe we only create the log when the pilot actually signs onto the system. Okay? So now we're not just creating a link between two existing objects, we're creating an object and creating a link between the two objects. So we start off with a create flight log, which is public. The plus symbol tells us that. Okay? And this calls the constructor a flight log. It's calling the constructor now. And then it's going to make a one-directional link to its new instance. Okay, so there's now a pointer or reference between flight and flight log. Then, secondly, the constructor is going to make the link back. It's going to say, okay, update my instance variable to say which flight I'm for. Okay, very simple, really. That's subtly different from the previous case. Okay, this is what we call boilerplate code. This is only pseudocode we're seeing here. But this is boilerplate kind of stuff. You implement associations like this over and over and over again in domain models. Very, very similar kind of styles of code. The important thing is to understand how to do it. There are other ways of doing associations, by the way, that involve more sophistication and lookup tables and things like that. But I'm just using simple references here. These are the most common ways of doing it. Class collaboration C, our old standby, the booking, passenger roll booking specific flight. Okay, we've seen this before, these three classes, our booking association class. So this is the pattern for where we create an instance of association class, booking, given to existing objects. So this is an operation, the public operation is make booking. See the plus sign there? Okay, that's the public operation. It has two arguments, which are the two objects, the passenger roll object, the specific flight, typically passed down from the user interface somewhere. Maybe it comes from a long distance away from some kind of travel agent's terminal or some website somewhere where you said, go ahead and make the booking. Ultimately, the command gets sent over the network, arrives in our system, and results in the make booking method being called. Okay? The make booking method, what does it do? It calls the constructor of booking. That's all it does. That's interesting. The booking constructor then is not public, but takes over most of the rest of the work. Okay, so the booking makes a one-directional link back to passenger roll, makes a one-directional link to the specific flight, and then calls the operations on either class, on either side, to make the pointers to it. So it calls the instance of specific flights method add link to booking, and it calls the instance of passenger roles method add link to booking to make the pointers. So we've got four references here, two-directional references. And all these methods, 2, 3, and 4, are non-public. They're collaborating methods that help get the job done. The main responsibility is the make booking. Now, here's a test of your understanding of this. Can anybody tell me a different way I could do this? There are several other ways, but there's one other way that is quite common, probably as common as this. I'll give you a few seconds to think about it. It has to do with the sequences with which the links are made. Who is doing the making of the links? No? No thoughts on that? Okay, let's walk through it. and then we'll see the difference. Okay? Passenger role says to booking, create yourself. Booking says, okay, I created myself, I'm going to make a link to passenger role in flight, and then I'm going to call code in flight to make the link this way, and code in passenger role to make the link back. And then we're done. That last step, booking, calling passenger role, add link to booking. I could avoid that. What could I do to avoid that? Remember, the entire thing that's going on here is this method makeBooking. MakeBooking is being called, and makeBooking calls the constructor, and eventually the constructor returns after all the work is done, and then makeBooking returns. Right? So makeBooking is the main program of this responsibility. By the time makeBooking returns, the booking's constructor has called another method of passenger role add link to booking to make the connection to booking. What I could do is I could have the constructor of booking not call add link to booking and just return and then have makeBooking finish off by making the final link. Okay? So let me just write that on the board, the sequence which I could do that. The reason why I'm pointing this out to you is to help you to understand there are different ways of doing these things. Okay? So I've got 3 classes here involved. I'm just going to label them booking, passenger, role, and SpecificFlight. Okay? So right now, we're calling the booking. Okay? This is the first step. Okay. While that is going on, we're making the link back to here. Okay, that's the second thing. Then this link to here, that's the third thing. And then this is calling this thing here, which is making the link to here. Actually, this, I guess it makes the link, it calls this one here to make the link here. That's done 4th, and this link is made 5th. But this link, this 5th one, is made under the control of the constructor. What I could do, instead of making it under the control of the constructor, I could make it directly under the control of the makeBooking method in passenger. Subtly different. Personally, I think it's much better to have the constructor take care of everything here. Okay, so I've got makeBooking, calls the constructor, and by the time the constructor finishes, everything's done. That's actually slightly less bug-prone than the other way I was suggesting. But there are other ways of doing it. If you don't understand that, then think about it carefully. Try and understand what I just said by reviewing the notes, and you can look at the video over and over again if you want to try and get the point. Okay, that's one of the purposes of having the videos. Anybody have any questions about it, though? All right. Class collaboration D. Changing the destination of a link. Okay, so now what I have is I have my SpecificFlight and my airplane, and now what I want to do is I want to change the plane. Okay, we discovered that one plane that's supposed to be flying us from Ottawa to Toronto is stuck in London, England because it got fogged in. Okay, or snowed in. Probably not the right city to be snowed in, but anyway, it got snowed in, and therefore it didn't make it to Ottawa, and therefore we have to put a new plane on to fly to Toronto. Okay? So now what do we have? We have an operation called change airplane, and this is going to have as an argument the new airplane that we're going to be adding. The airplane knows that the airplane that's already there, it's got an association to that. As an argument, there will be a new airplane. So the steps that the public method would do, the change airplane method would delete the link to airplane 1, would make a one-directional link to airplane 2, okay, call operation 2, which is going to be in airplane 1, okay, so airplane 1 has got to delete its link back to the flight, and then it's going to call operation 3, which is making the link to the new, making the link from the new plane to the flight, okay. So this is another sequence which is quite common from changing associations. In this case, changing a link from one instance to another instance. Okay? Okay? And there are other sequences with which this could be done. This is not the only sequence, but this is a logical sequence, easy to understand. Okay? Notice that add link to specific flight, this private method, is being used both by responsibility A and responsibility D. Okay, so we're reusing code here, which is very good. Responsibility E is searching for an instance. Okay, searching for a crew member associated with a flight that has a certain name. Okay, the crew member has a name, we want to search for that. Okay, so the responsibility, get name, is going to be in employee role, and it says create an iterator over all the crew members, links of the specific flight. So what we're going to be doing here is we're going to be searching for through all the flights, okay, until it finds a match, until it finds a matching name. Now I just made a mistake there. The public method here, okay, is find crew member. Get name is also public. Get name is the method in employee role, but what's going to be doing this iteration is find crew member. Okay, we've got a flight. We're going to be iterating over all of the links to employee role, and as we go through each of the roles, we're going to be saying, does the name get name? Does the name match the argument to find crew member? If it does, return it. If not, keep going. Okay, so loop through all of these, the asterisk crew member, the multiple instances of employee role attached to the flight. The point is that it's calling get name. But now here's an exception. Get name is collaborating, but get name is also public. Because get name can also be used in its own right. The user interface can call get name on an employee role in order to display the name. Okay? So we can have collaborating methods that are private and collaborating methods that have also responsibilities in their own right. Any questions about this? Okay. So I've told you abstractly how to go about implementing these things in an abstract way by, here are the methods that you call. In Java, we have certain specific code idioms that we're going to use, okay? We're going to implement all our attributes as instance variables. We're going to implement our generalizations using extends, interfaces using implements. That's pretty straightforward. Associations using instance variables as well, normally. And each association is going to have an instance variable on either end. Okay, so our booking is going to have an instance variable pointing to flight, and the flight is going to have an instance variable pointing to booking. Okay, what we're going to do is we're going to think, as we do the implementation in terms of the code, as each two-way association, we're going to think of it as two one-way associations. Okay? So where the multiplicity at the other end is 1 or optional, we're just going to have a variable of that class. So a booking has one specific flight. So we're going to have an instance variable of type specific flight in booking. Simple, right? On the other hand, if we have many, in other words, the upper bound is anything other than 1, then we're going to use a collection class, like list or vector or array list. There's a whole bunch of different possible collection classes. List is actually an interface in Java. There's a whole bunch of collection classes we can use. Which one we use depends on some detailed issues in design we'll leave aside for now. So we're going to have an instance variable in SpecificFlight that has a set of bookings. It might be declared as an instance of class ArrayList, for example, which contains our bookings for that flight. Let's look at actual code. Okay, first of all, class SpecificFlight. These are examples of some of the instance variables we have. So we've got date, which is implementation of our date attribute. I'm using the calendar class in Java to do this. RegularFlight is implemented. This is an association that is the specific flight is one regular flight, so it's a type regular flight. I have an airport, terminal of airport. This flight is going to go from one airport terminal, so it's declared a type terminal. One airplane and one flight log. So these first 5 attributes are implemented just as instance variables of the type of the class that's at the other end. Then I have the flight having a set of crew members. So I'm using array list for that. And I have a set of bookings. Okay? So I have a array list of that. In C++, what I would typically do is I would typically use the C++'s template facility, and that means angle brackets, and I would say, you know, some collection class angle bracket booking. So I would say what actual type of object can be put in that array list. In Java we can't do that. In Java we just have to use the name of the collection class. At least Java can't do it yet. All right. So those are the declarations of our instance variables that are going to be used to capture the attributes and the associations. Date is an attribute. Regular flight, destination, airplane, flight log are associations. Implementation, all of them as instance variables. So crew members and bookings are also associations. We have a constructor. Okay, this constructor is going to take a date and a regular flight. It's going to be called by the regular flight, and it will allow us to schedule a particular occurrence of that flight on a particular date. So all we're doing in the constructor is we're assigning the value of the attribute date and the association, okay, regular flight. So notice that when it gets down to code, attributes and associations have a lot in common with each other. They're both implemented as instance variables. Here's regular flight. Regular flight has a list of specific flights associated with it. This is the implementation of the association. And here is some code for adding specific flight. Okay, this is one of those responsibilities that we had a while back. Okay, so it's going to be passing to the it's going to be passed the date. Okay, so the user interface or the scheduling system, whoever calls this, is going to know the date that it wants to schedule. So it passes the date, and then we have the lines that actually implement the various steps of our responsibility. The first thing is to create the new specific flight. Second thing is to assign that. The first thing is to declare. I'm declaring the new specific flight. Then I'm saying create a new one with this date and myself. Okay, so new specific flight, bracket, a date this is calling the constructor a specific flight and assigning it to my instance variable, new specific flight. Actually, new specific flight here is not probably going to be an instance variable. It's probably going to be a local variable. And then I'm going to call on that. I'm going to say add to my specific flights up here, my specific flights instance variable, this new instance that I just created. Okay, so a lot of the work is going to go on in this constructor of specific flight. Constructor of specific flight is going to go on and do a lot of that work. Well, you'll have to take a look at the code to actually see the rest of that. But this sort of gives you a flavor for how it works. Okay? The best thing to do, the best thing to learn how to do this is to take a piece of code that's implemented like this and make a change to it. Add a new responsibility, following the pattern of existing responsibilities. Okay? See how it's done in one subsystem or between one set of classes. Follow the same pattern. It's like cloning code, except that what you're doing is you're copying over just 1 or 2 lines of code, little idiom that is saying, and they're going to be totally changing the names of the methods and the values of the attributes and so on. Okay? So that brings us to the end of Chapter 5. Are there any questions about the material in Chapter 5 so far? Don't forget to ask your TAs, okay, in the lab. They will be going over other examples in the lab next week of problems in Chapter 5. I strongly recommend that you work through some problems yourself. There is an answer manual available for you to check some of your answers. Go get the answer manual, see which answers are there. The web page tells you with little asterisks which answers are there. Do some questions, and then check out your skills by comparing your answer to the answer that's given. So, we're going to continue now with Chapter 6. Chapter 6 is basically more about class diagrams. In particular, it is about design patterns, which are typical occurrences in design that are occurring over and over again. They're solutions to common problems that people have codified and said, this is a good way of solving this particular design problem. Okay, recurring aspects of designs. Okay, outline of a reusable solution to a general problem encountered in a particular context. The notion of patterns was brought to the public's attention a few years ago. Several books are written about patterns. And you just pass me that book for a second? This book here, this random chance, this is the book Gamma, Helm, Johnson, and Blissards, is actually the most well-cited book about patterns. It's just pure chance that my assistant happens to have it on his desk today. These are the people who brought patterns into the public knowledge in the software engineering community in the mid-90s. Okay, and a lot of the patterns we're going to see today come from this book. It's called the Gang of Four book, because there's 4 authors. There have been many, many other books about patterns. On the website, I've got links which will link you to a vast array of information about patterns that you can learn. And basically what patterns allow people to do is to think about design at a more abstract level. You don't have to think in detail about all the associations and all of the twiddly things you have to do to implement. You can say, I've done that before. That's a piece of design that I've done before, or that the Gang of Four authors have done before. They told me how to do it. They've analyzed what's best and what's not so good. And here is the way to implement this piece of design. Okay? Some of the patterns here are patterns that I have come up with, that I have discovered myself, and are being published in my book for the first time. So there's some unique new patterns in the book, and there are also some patterns that are from other authors, which I've given reference to. A pattern should be general, should be applicable in a wide variety of situations, and should contain a solution that people believe in. The community believes in this solution. It's being shown over and over again in many designs to be a good way of doing things. People will look and say, I see your design and I see you're following a certain pattern. Okay? It also allows you to learn from the experience of others. You don't have to repeat the same mistakes that others have made. You can just learn a set of patterns and learn from the experience. By the way, I talked about patterns in software engineering coming from the Gang of Four. Actually, patterns came have a much deeper history. Patterns came from the architecture community. The fellow called Alexander, who is very well known for developing concepts of patterns for building architectures, and is often considered the grandfather of the patterns community. Patterns are also found outside of software engineering in many other areas. So started in architecture, they were adopted into software engineering by a number of authors, including the Gang of Four. There are a number of ways of describing patterns. Fundamentally, a pattern has to be documented. It has to be written down. It is a written thing. It includes diagrams and so on. But everybody who writes patterns has a structure for writing down and describing the information in the patterns. Different authors, however, use a different structure. Okay? And there's a lot of dispute in the community about what headings to use. We're not going to get into that. I'm just going to say, from the book and from my personal experience, the headings that I'm showing on slide 3 are a good set of headings to use. They're not the same headings as the Gang of 4 uses, but they're related. Okay? So, the context. What is the situation in which the pattern applies? When you want to use a pattern, what you're going to be doing is you're going to be saying, does this design situation I have match the context of the pattern? If it does, I can use the pattern. The problem is describing the design difficulty that you're having. What is the issue? What is the problem that people who are doing design are facing and the dilemma they're facing? The forces, and this is an interesting word that takes a little bit of getting used to, the forces are, what are the issues that can be brought to bear on this context in order to come to a solution? Sometimes the forces relate to different kinds of qualities. So, you know, we're weighing whether we're interested in efficiency or whether we're interested in maintainability. So one force is efficiency, that is pulling us towards making one design decision. Another force is maintainability, that is pushing us towards another design decision. So I talk about being pushed, right? Well, the word force can therefore be thought of as relating to the forces in other branches of engineering, where you're balancing weights on beams in mechanical engineering or things like that. That's the analogy they're trying to draw here. You know, when you're doing an engineering analysis in mechanical engineering, you do some calculus to figure out how to balance the beams and get the right forces and the right tensions. In software engineering, what you're doing is you're balancing things like maintainability, reliability, and other qualities. The solution is the recommended way of doing the design, given the context, which sort of tells you what the weightings, relative weightings of the forces are, and the problem, and the actual things that you're considering. Anti-patterns is an optional thing. Anti-patterns are things not to do. Typical mistakes people make. Okay, a lot of authors will have a whole separate series of documents describing anti-patterns. I like to sort of list anti-patterns as part of the patterns. Things not to do. Mistakes not to make. Related patterns are other things to think about. Maybe alternative designs that you might also want to consider. And references is who developed or inspired the pattern. A few things about the patterns community in general. Okay? The patterns community is a community of people in software engineering which have come to agree that patterns should be, generally speaking, considered, preferably in the public domain. Okay? So I will grant people permission to take and apply the designs that I have published as patterns here. I'm not going to patent them. Notice the difference between the word pattern, ending with an N, and patent, ending with a T. Okay? Non-English speakers often don't realize that those are two totally different words. And they almost have opposite meanings. Okay? A patent is a license given to you by the government to produce something and charge other people if they want to do that thing. A pattern is supposed to be, according to the patterns community, in the public domain. It's also considered, the patterns community also has, you know, they have a series of conferences and they have a number of principles they go by. For example, you can create patterns in any area of human endeavor. You can create patterns following this kind of style for how to do photography, for example, or how to bake cakes, for example. You know, if I want a cake that is going to, you know, have a certain properties, well, what kind of solution, and it becomes a recipe. You know? And this community says nobody should create patterns for doing unethical things. That's part of one of the rules of the pattern community. Don't create patterns for how to do bad things, just good things. You know? That's part of their ethos in that community. You can read about that in the book. Let's actually start talking about some patterns. First pattern, and the first couple of patterns we're going to look at are patterns that occur in the analysis stage of class diagram creation. These are patterns, some of which we've already seen. Okay? What I'm going to do in each case is I'm going to jump to the figure and then go back and talk about the patterns. So we're going to jump directly to slide 5. And we're going to take a look. Abstraction-Occurrence. One abstraction has many occurrences. Okay, notice I'm using the little angle bracket symbols, the little Guillemette symbols indicating stereotypes. So this is saying a special class. This is not real classes. These are abstractions of classes called abstractions, and special classes called occurrences. That, down below I have real abstractions. So TV series is a real abstraction. Episode is a real occurrence class. So TV series to episode follows the abstraction-occurrence pattern. The issue here is what if we have a situation, okay, where we wanted to model the notion of something being broadcast, a show being broadcast. The user requirements say that there are a certain number of shows that have names, producers, and so on, and each show has a number, title, and story. Okay. It's very common in ordinary English to not distinguish between the abstraction and the occurrence. You might just use the word show or TV program in ordinary English in the requirements. Very, very common, not in English, to make the distinction. And that leads people to immediately create a single class called TV program or show with all the attributes in it. What we have to do is we have to recognize that things which have occurrences are following this abstraction-occurrence pattern and actually should be two classes. So we have a series. Okay, people talk about the show as a series, and they talk about the show as individual episodes of the series. You've got to break those up into two different aspects. The series has the name and the producer of the whole series, maybe the production company, and the episodes each has an individual number, which is used by the production team, a title, which is maybe displayed in the TV guide, story synopsis, which is also displayed in your local television guide or on the web or whatever, and presumably a bunch of other stuff. The whole screenplay would be one per episode too. The important thing is not to make the mistake and make this into one class. Here's another example: title and library item. Okay, so I'm building a library system, and my clients tell me I have books in the library. And books have names, authors, ISBN numbers, publication dates, and barcode numbers. Okay, I create a single class that has all of that. But I've got to recognize that in actual fact, there's a distinction between the title, or the abstract book itself, like the book Gulliver's Travels, and the particular holding of that in a library. The library might have more than one copy, because in a big library, popular books, the library has several copies of the same title in order to be able to not have huge lineups of people trying to borrow the same book. Okay? So it's very important to distinguish between the overall title and the individual items. Abstraction, occurrence. Okay? Let's go back to slide 4. And this is just how we would write this pattern in a pattern document. So in the domain model, we find a set of related objects, occurrences. Okay? So shows, library books. The members of the set share common information. Okay? So there's common information about some of the books have the same title and author. Well, it's because it's, the library has got several copies of the same book. Okay? But they differ from each other. Every individual copy's got its individual barcode number and is loaned at different times to different people. Okay? So we are going to have the abstraction object to capture the commonality. We are going to have the occurrence objects as well. The question is, what is the best way to represent these occurrences in a class diagram? And the big force here is avoidance of duplication. Okay? Avoidance of duplication. Duplication itself tends to be bad in design. It leads to bugs. It leads to inconsistencies. Okay? So avoidance of duplication is a positive thing we want to try and achieve. But nevertheless, we want to represent all the data. So all the data without duplication. We've seen the examples on slide 5. On slide 6 is anti-patterns. These are typical mistakes made by people. Okay? Do not make these mistakes. Avoid these mistakes in your assignment, avoid these mistakes in your exams, and when you go out into the workforce, avoid these mistakes. First mistake, jam it all together. So, I'm not distinguishing among the various books. So, in my library, I've got 2 copies of Moby Dick and 2 copies of Gulliver's Travels. I have 4 library items. Okay? One library item, name Gulliver's Travels. Second library item, name Gulliver's Travels. Third one, name Moby Dick. Fourth one, name Moby Dick. So I'm duplicating. And each time I have a duplicate book, I just repeat the name, repeat the author, repeat the ISBN, repeat the publication date, repeat the Library of Congress. Although the barcode numbers will be unique in each instance. That's bad because I'm repeating the information. If I ever want to go and change the name because I realize I made a spelling mistake, then I have to change it in all the occurrences. That's the first sign of a problem. I don't want to make changes in multiple occurrences. I want to make a change in one place. And that's why I would use this abstraction. I can make the change in one place, just in the title. Second anti-pattern, second mistake, very common mistake by naive beginners, make subclasses, Gulliver's Travels, Moby Dick, of library item. We've already talked about this being bad. These are instances. Every single time I have to create a new, buy a new book for the library, I have to program a new class. That's stupid. Okay? So therefore, it's obviously the wrong answer. But I will find some people doing that. Just, your reflex should be to abstraction occurrence, not create subclasses under this kind of circumstance. Because obviously I can't program separate classes, and there's no need to. There's no different attributes. The attribute is name, author, ISBN, publication date, Library of Congress. It's all inherited from above, and so there's no difference here. These are just instances. So that's wrong. And the third case, subclassing library item from title. This is more subtle. This is very wrong, but it is a very common mistake. A library item is a title. That sounds wrong in English. But what if I called this thing book? Well, that would have been a bad choice of name because book has multiple meanings. The word book can be applied to either the abstraction or the occurrence. Right? Right. So, I chose the word title to distinguish it explicitly from the word book. What we'll typically have is people creating book as a superclass and specific book as a subclass. Okay, or something like that. Can somebody tell me why this is wrong? What is wrong with making the library item a subclass? This is a test of your deep understanding of this pattern and of class modeling. You should all go out of this class, or by the end of the day, certainly by the midterm, say, I obviously understand why this is wrong. This encapsulates a whole bunch of knowledge that I've been teaching over the last 5 or 6 lectures. Okay, you should clearly understand why that's wrong. Hands up, yeah, I see some, yes, why do you think it's wrong? Well,
one thing, if you made multiple instances of library item, you would end up with multiple instances of title. And
he's exactly right. Everybody hear him. He said, I'm going to have instances of library item. I'm going to have instance of library item for every book in my library, right? But that's going to inherit name, author, ISBN, publication date, Library of Congress code. So I'm effectively, this design is absolutely identical in terms of the objects I'm going to have to the one on the far left, the library where I just have one class. Because I'm going to have the same objects. I'm going to have one object with all this data in it for every single copy of every single book. Same data. It's just I split it into 2 classes, but fundamentally library item is a title. Every instance of library item is an instance of title. So every instance of this bottom class is going to have all of the stuff in it. Right? So making these occurrences subclasses is wrong because I'm not getting rid of my duplication. The duplication is going to be there just the same. I've got to create an association, one-to-many, which allows me to avoid duplication. One end is where the unduplicated stuff goes, and and then what's left over that does change with each occurrence goes on the many end. Okay? In the airline system we looked at, there was an abstraction occurrence. What were the two classes involved? What were the two classes in the airline system where there was an abstraction, a bunch of occurrences? Hand up. Hand up, yeah. Regular flight, specific flight. That is exactly an abstraction occurrence. You will see abstraction occurrence occurring over and over and over again in domain models. Almost every domain model has at least one. That might be a slight exaggeration, but almost any domain model of a decent size has one. Many of them have multiple cases of it. Be on the lookout for it. Okay, I think we're going to leave it there. We're going to pick up with more patterns on the next day. And I'll see you, no class on Friday, so I'll see you next, I guess you guys next week from